Okay, part two, everybody. My next chi-square test. This is Unit 5, Lesson 50, Test for Independence using a contingency table. So one thing about this particular hypothesis test, I'm going to use Pfeiffer notes for this one again. Dr. Pfeiffer once, I'd say about, 15 years ago, had a student who was a freshman in college, took a stat course, and came back days after he took his final and said, Dr. Pfeiffer, I want you to know that not only was there a chi-square test for independence on my final exam, but this exact question was on the final exam. So keep your notebook, everybody. You never know how in handy it can come. All right. So a management consultant wants to know whether there is any relationship between sense of humor of a salesman of industrial chemicals, okay, and his ability as measured by volume of sales. He gives 500 salesmen a certain objective test designed to measure sense of humor and obtains the following results. So a person can have low, average, or high volume of sales. I can understand how that can be measured, but poor, average, and excellent sense of humor, this is where the question got me. How do you measure that? That's besides the point. Decide at the 0.05 level of significance whether sense of humor is, in fact, independent of sales. Okay, this is another one of those hypotheses that are absolutely irrelevant without a verbal. So if you cannot read this Doc Pfeiffer handwriting right here, let me take you back into the Wayback Machine right now, all the way back to Unit 2 when we did the addition rules and the multiplication rules. Do you remember this? This is day 2 of Unit 2. Crazy how far back this seems now, right? But the multiplication rules dealt with the word independence. And the multiplication rule stated that if events A and B are independent of each other, then the probability that A and B occur is the probability of A times the probability of B. And do you recall that the way to show the word and symbolically in logic symbol form is the intersection symbol? So let's go back to today's notes. Look what Doc Pfeiffer wrote here. Instead of A and B, he did the probability of row I and column J equals the probability of row I times, ooh, that's an I, times the probability of column J. So instead of using the letters A and B, it's row I. So I represents the rows, J represents the columns. That's it. And again, that's meaningless without a verbal. The verbal is that sense of humor is, in fact, independent of sales. The null hypothesis is boring. It's always boring. Things are independent. Nothing's going on. Everything is equal. Everybody's just fine. It's H1 where things really get juicy. The probability of row I and column J does not equal the probability of row I times the probability of column J. Sense of humor is not independent of sales. There's a relationship. The alpha level is 0.05. Chi-squared is the exact same thing as it was for our chi-square goodness of fit test. The assumptions are a bit some same, some different here. Random sample of data. Okay, great. The assumption number 2. This can be a little bit wordy right here. Each observation may be classified into one of I different categories according to one criterion and exactly one of J different categories of another criterion. In other words, I would be the sense of humor, that criterion. And there's 3 categories of it. J would be volume of sales. And that's also 3 categories, low, average, and high volume of sales. Okay, and do you remember the E's from what we just did the last time? E's stand for expected frequencies. Expected frequencies. And that's the E's. So the expected frequencies are all greater than or equal to 5 for all cells. So we're going to once again have to calculate the expected numbers. We're going to reject HO if chi-squared is greater than. It's not just k minus 1 degrees of freedom this time. It's I minus 1 times j minus 1 at the alpha level. So let's just plug this in right here. There are, if we go back up to the table, there are 3 columns and there are 3 rows. So I is 3 and j is 3. So this would be 3 minus 1 times 3 minus 1, which is 2 times 2, which is 4. So it'd be chi-squared with 4 degrees of freedom at the 0.05 level, and that's right here. And chi-squared with 4 degrees of freedom, 0.05 level, just one more time to practice. Go to 4 degrees of freedom, go to the 0.05 level, and that's 9.488 right there. 9.488. Bob's your uncle. There you go. Okay. You could pause the video and you could read my words right over here, seeing if there's some kind of connection or relationship or AKA correlation between things. In general, when the data is grouped together, you could use this test to see if there's a relationship or correlation, or see if there's some sort of dependency of one variable upon another. If the data is independent, we're going to use a correlation test. I'm sorry, individual, not independent. If the data is individual, non-grouped, use a correlation test. That's unit 6. We're getting there. Computations. If you wish to compute by hand, please feel free and look at this. Pause the video. Take your time. It's not difficult. If you'd like to know how to do this on your calculator, which is what I'm going to show you, then watch right here. So for this one, I'm not going to go to stat. I'm actually going to hit second and matrix. Matrix is in blue right here. So hit second matrix. And anytime you want to enter or edit a matrix, you arrow to the right and hit edit. I want to edit matrix A. But what are the dimensions of that matrix? It's 3 by 3, right? There's 3 rows. So hit 3, enter, 3, enter. And a 3 by 3 skeleton appears. Then just enter your numbers in by row. So I have them in front of me. 38. Next in that row is 41. Next in that row is 29. Then 72, 129, and 87. Last row, 17, 45, then 42. Okay. Now that I have entered the matrix and the matrix A, I actually will go to stat. Do you notice how we always do stat and then just calc? We never go to tests until right now. We're going to go to tests, and I'm going to arrow down. There's a z-test, t-test. Really? Really? 2 sample z-test, 2 sample t-test, proportion test. All this stuff is right here. Take this out. Chi-square test. Go to chi-square test and hit enter. Our observed matrix is in matrix A. I know we didn't put one in B. I'm going to say that again. We did not put any matrix in B. It will actually calculate one for you. Just watch. Go to calculate, hit enter, and your chi-square value is 11.787, really. 11.787. I'm going to apologize before I go back to the screen. I rounded incorrectly, so sue me. You're going to see what I'm talking about, but 11.787 roughly. Okay, so let's go to our notes once again. Let's finish this up. I wrote 11.786. If you calculate it by hand using the same methods that you did before, observe score minus the expected quantity squared divided by expected, and do it for all 9 cells, you're going to get chi-square. If you are curious and forget what I just did on the calculator, you could always go to page 14 in the calculator packet that I gave you, and you'll be right there. Now, question. We are going to reject if we get greater than 9.488. Did we get a number greater than 9.488? We certainly did. So we are going to reject HO. And this is all Doc Piper handwriting, but thankfully, scroll down, I typed it all up for us. Oh, thanks, Miss Claudie. Don't worry about it. It's all anything for you guys. So we're going to reject HO, and we're going to accept H1 this time. That sense of humor is not independent of sales. That means there's a relationship between the two. One note, what if you fail to reject this test tonight for homework? If you fail to reject HO, that means you're going along with HO. And what does that say? That sense of humor is independent of sales. And guess what? Let me go on video for a second. If sense of humor is independent of sales, you're done. No best point estimate, no anything like that. They're independent. They just have nothing to do with one another. Okay, but we didn't say that now. We said that they are, in fact, dependent upon each other. Sense of humor and sales are related in one way, shape, or form. Doesn't say how yet, but it just says. So how related are they? Well, we find the strength of the relationship. Once you reject HO, and only when you reject HO, you need to find the strength of the relationship, and it's measured by something called the contingency coefficient, which is the letter C. You take the chi-square value that you calculated, divide by chi-square plus n, square root the whole thing. Again, I even rounded poorly here. It should have been 11.787. I wrote 11.86. So sue me. You get the point. And the chi-square, I'm sorry, the contingency coefficient is 0.15. Your big whoop-de-doo. What does that represent? Well, you need a continuum to put this on. First, you need a minimum value. The minimum value of C is always 0. Put that on the continuum. Then you need a maximum value. The maximum value is a computation in and of itself. It's the square root of Q minus 1 over Q. What is Q? We're going further down the rabbit hole. Q is the number of rows or columns, whichever is smaller. Well, in this problem, we have 3 rows and we have 3 columns, so it really doesn't matter. It will matter if there are a different number of rows and columns, but so that means Q is 3. So 3 minus 1 is 2, divided by Q, which is 3. Square root of 2/3 is 0.82. I put 0.82 at the top of the continuum. Then I put wherever 0.15 or wherever C falls on the continuum. Further to the left is a weaker relationship. Close to the center is a moderate relationship. Close to the right is a very strong relationship between the two variables. Now, mind you, 0.15 might be right about here. So if you say I reject HO and it appears that there's a weak relationship, I'd be fine with that. If you said there's a weak to moderate relationship, I'd be fine with that. If you said there's a moderate relationship, I'm cool. If you said there was a strong relationship between the two, that's when I would probably throw a point off. Okay. Just in general, this is a theory. There's 2 possible perfect relationships. You know, maybe the better sense of humor you have, the more sales you get in a perfect linear pattern. Maybe, since it's industrial chemicals, the better sense of humor you have, the less sales you have. Maybe you're like, hey, you know, industrial chemicals is a very serious thing. I don't need any jokes, just the facts. So to be absolutely honest with you, this is not, you know, they're perfect relationships, but you don't need to write that down. Okay. And ladies and gentlemen, that's it. If you have any questions, ask me. See ya.